So again, welcome to my first RAG application. First, we are going to answer some of the questions that are proposed in this notebook and that are really relevant for having an understanding and knowledge about how this kind of pipelines like RAG work. Let's go to question one. Let's see if I can find it. Okay, question one. So it says, the default embedding dimension of text embedding 3 small is 1536. And is there any way to modify this dimension? And what technique does OpenAI use to achieve this? So in fact, there is a way to modify this dimension, and you can control it by modifying the dimensions parameter, which specifically for text embeddings very small, it ranges between 256 and the default value 1536. And how does OpenAI achieve this reduction in dimension? So it uses a specialized training technique called Matryoshka representation learning that you can find more about how does this technique work in this archive paper. So now let's answer question two. It says, what are the benefits of using async, so asynchronous programming, when collecting our embeddings? Using async approach to collect embeddings means that requests don't block each other. So by nature, asynchronous programming lets you run tasks in parallel. In the sense that the program can send many requests at once and keep working while waiting for responses. So the benefits we are experiencing are faster throughput, better resource usage, and it scales better as asynchronous code handles larger batches of text. Let's go to the question number 3, which is also very relevant, and says, when calling the OpenAI API, are there any ways we can achieve more reproducible outputs? So why is this relevant? Because with the new GPT-5 models, they have substituted or got rid of the temperature parameter. And now the way we can achieve those reproducible outputs, because remember that LLMs by nature are stochastic models, so a way to achieve this reproducibility is by pinning a specific model snapshot. And also we can track prompt performance with the bus. Let's go to question number 4. Okay, what prompting strategies can we use to have a more thoughtful, detailed response? With the new GPT-5 models, we have a parameter called reasoning, or reasoning effort, which takes 3 modalities, low, medium, and high. And basically, when you are setting the effort to high, the model takes more thinking steps before giving you the response. So it has time to plan, think, and give you that detailed response, thoughtful response that the question is asking. Now, let's watch my RAG implementation. So what things have I done to do this RAG pipeline? So first, I substituted OpenAI API models with Grok API models. How I did this? By creating a class called ChatGrok and modifying chatmodel.py, adding this class. The main difference is that instead of requesting a response from the OpenAI API endpoint, responses endpoint, we request a response from Xine. And what are other changes that I have done through my retrieval augmented pipeline? Well, as we can see, the retrieval augmented QA pipeline takes a vector database, and I change this database with one that uses an algorithm called approximate nearest neighbors. How does this work? So, by using this algorithm, what we are doing is dividing the vector space into clusters. I use the technique IBA taking advantage of phase built-in method, and we divide the vector space into clusters in which we select the 10 with the parameter mprov, the 10 closest clusters to our query. And how are these clusters selected? With the quantizer. In theory, in this exercise, as we have seen, we have this text. But if we have millions and millions and millions and millions of embeddings, by using this technique, approximate nearest neighbors, this search of the most similar query is much faster. So thank you so much, and this has been the presentation for my first RAG pipeline. Thank you.